All right, this is Mr. McMurray, and we're going to work on the Gravity It's the Law lab. And the good news is I don't believe there'll be any graphing whatsoever required on this one or charts. So those are usually the ones we have the most fun with. All right, and basically you're going to have a simulation from PHET videos, which are usually fairly good. So I like them a lot. But yeah, basically, you have some questions here based on the picture. Let me launch the simulation over here so we can see that. Okay, and basically, if we want to move them, we can either drag the sphere forward or closer and see how that affects the force of fear. Same thing, we can move this one farther away. We can change their masses, make a bigger mass here, and we can make a bigger mass here or smaller mass here, or whatever. And basically, we're just doing some changes with the distance and the mass of the objects. And how does that affect the gravitational force represented by the little vector arrow here? Okay. And then basically, it's going to ask you some questions about that. This one, in order for us to determine, for example, the changes in mass, what can be changed, how many things can be changed at once, and how many things need to be stayed the same. It's kind of what it's asking there. Okay. And then it gives you a formula. Do you agree or disagree, and why? All right. And then we have some other things here. This just tells you what is this number equal to. That should be in our notes. Drag it up here where it belongs in the formula, and so forth with all these other things. Okay, what they mean. Here you just put a mass for that one, and then put a mass for the second one, and then you adjust the masses so they're far apart, and then you would build an equation. Okay, we want to find the force of gravity, which would be A, and that's going to go here, and then we would plug in what we need to multiply and divide in order to get that. Okay, and then you're going to put an answer here. All right, and it will give you a little thing about writing in scientific notation, but you need to put your answer there. All right. This one, set your masses and so forth, and find the force between them and write your answer again. Okay, so those are just going to be kind of doing that. I think that's fairly straightforward, hopefully. All right. Now, gravitational force. This is once you do the thing, you can set the masses this way. You can set the distance. This one, of course, is the universal gravitational constant, so it's not going to need to be changed. And put your answer, and then correct force vectors that you would see. If they had force vectors or arrows over both of them, what would they look like? Would it be smaller and bigger? Would it be bigger and smaller? Or would they be equal on both sides? Okay. Now, then this was talking about, and was talked about in the notes, distance is related to the force of gravity in an inverse square. In other words, the bigger the distance, say you double the distance, then it's going to be the inverse square of that. The inverse of 2, or 2 times as much, is 1 over 2, which would be a half. And then squared, 1 squared, 2 squared, would be 1 over 4, or 1/4 as much force. Okay? If you start with a fraction, say 1/3 is far apart, that'd be 1 over 3. The inverse of that would be 3, and then you would square it, so it would be 9 times as much. In other words, if they're closer together, it's going to be a much bigger number, and if they're farther apart, it's going to be a much smaller number. Okay? All right, so it's going to ask you some questions about that, and then what about, once again, changing the distance again. All right, then they're going to make it a little more complicated. They're going to change 2 things at once. For example, if the distance between the masses is divided by 2, r divided by 2, or that would be half. Okay, the inverse of 1/2 would be 2. Flip it over, 2 over 1 instead of 1 over 2. And then you would square that. 2 squared is 4. So this would make all of these going across here 4 times as much. But now you're doing something different to them in this column. Now the mass is half as much. That is a direct relationship, not inverse nor squared. So if there's half as much mass of one of them, there's going to be half as much. So this one says it'll be 4 times as much. This one says it'll be half as much. So if you do both of those, it'll be 4 times 1/2, which would be 2. And so you would find 2 down here, drag it up, and say force will be 2 times as much as it was before you did that. Okay, so the same thing here. You're going to figure out what would happen on this side, and then what would happen on this side. And then if you did both of them, that's the answer. That would go right here. Okay, now notice this one is filled out. So basically they're telling you, if you're paying attention here, is that if you have just the same distance, this one's going to make it half as much, which is what we said. This one is equal, so they're going to be the same, or 1F. And if there's twice as much mass, it's going to make it 2 times. So that tells you what each one of those does to them, which should be a good hint there. Okay, now this one's going to be a little tougher. This time they want you to find what the mass of the second one would be. Basically, and solve for the second mass if they give you all the other stuff, okay? Well, we know what G is, and G goes on the top. Let's go look at our formula up here at the top just so we can see that. Okay, we're going to have to solve for this formula, all right? If we want to get M2 by itself, we need to get rid of everything else here. So we first of all have to multiply both sides by r squared, which would cancel on this side. So you have r squared times the force of gravity, okay? You would have to divide by the things that are going to end up on top. So divide it, divided by G, and then you'd have to divide by mass number 1. So basically it's going to be this times this divided by this times that. Okay, and that would be how you would set up your formula down here. And then you would put in the information that they give you and solve it, I believe. Let me see. Let's go back down here. Okay, M2. First of all, you set up that formula, and you can look at it. All right. Then you would I apologize. Maybe not. Am I wrong there? Okay. All right. The force is provided for you as well as the mass. Okay. Oh, so this is in the simulation. Excuse me. I'm sorry. My fault. You do need to set the formula like we said here. Now, this time they're not going to give you mass number 2. They're going to let you decide. They give you the force. It's going to give you the distance. Okay, and you can calculate the distance between the center of gravity here and the center of gravity there, and they give you the mass of the first one. So they want you to figure out how big must the second one be. All right, so my bad here. So first of all, the mass of M2, you would have to plug the force and the distance and the mass of this one and universal gravitational constant, and plug those together and get your answer. Okay, that would do that. Now, then it wants to know if you move them to 2 meters. Okay, so basically be using the same information, except for now your distance would be 2 meters apart. Okay, so you need to make sure that these are 2 meters apart. So move them so that they're 2 meters apart. And then you would, once again, solve for the force. Okay. All right, then determine the new force compared to the original force if mass number 1 is doubled. So once again, what happens when you double the mass? And there you go. All right. I don't know sure how to be clear about those other than to, if you have trouble with the formulas or how to reset them up, let me know. I know I'm only giving you this as a oral thing, and that may be a little confusing, but hopefully that will help. All right. If you have any questions, please send me emails, so forth like that. Enjoy the lab, and sorry I'm a little bit late on this one.